Welcome to our presentation on environmental pollution. Today, our focus will be on water pollution, a critical issue affecting ecosystems and communities worldwide. This presentation is a collaborative effort by Group 4 Together. We aim to explore the causes behind water pollution, its far-reaching effects, and potential solutions to address this pressing problem. What's water pollution, you may ask? Water pollution, based on Oxford Dictionary, is contamination of fresh water by pollutants. It refers to the contamination of water bodies, such as rivers, lakes, and oceans, by harmful substances that degrade water quality and make it unsafe for use. This type of pollution poses significant threats to aquatic life, disrupts ecosystems, impacts human health, and reduces the overall quality of water. Common examples of water pollution include oil spills, the discharge of chemical waste from industries, and untreated sewage being released into natural water sources. As you can see, here are some of the factors that contribute to water pollution. Firstly, industrial discharges. Industries are a major source of water pollution due to the release of untreated or poorly treated wastewater containing toxic chemicals, heavy metals, and harmful substances. Thermal pollution from factories further disrupts aquatic ecosystems by altering water temperatures. Secondly, agricultural runoff. Excessive use of fertilizers and pesticides in agriculture leads to runoff during rainfall, carrying these chemicals into water bodies. This runoff causes eutrophication, where algal blooms deplete oxygen levels, suffocating aquatic organisms. And last but not least is urban runoff. Urban runoff, like oil spills, introduce harmful hydrocarbons and toxic compounds into the water, poisoning fish, marine mammals, and other aquatic organisms. And to make it worse, the long-lasting nature of that, its harmful effects persist for years. Now let's move on to the experiment. The experiment that we're conducting is about evaluating the severity of oil spill. The objective is to assess the impact of an oil spill on water quality and aquatic ecosystems. The material needed are a small tank or container, freshwater, motor oil or vegetable oil, absorbent materials, test kits for dissolved oxygen, DO, pH levels, and turbidity, measuring cups, and dropper. You can also read on how the experiment is conducted. TOEs are our expect outcome during the pre-spill. Baseline water quality will show normal DO, pH, and low turbidity. And when the post-spill, the DO levels decrease as oil limits oxygen exchange with the atmosphere, turbidity increases, and pH may remain stable depending on the oil type. Lastly, the after cleanup, we'll see partial improvement in water quality, but oil residue might still impact the perfect outcome. By doing this experiment, we come to the conclusion that this demonstrates how oil spills harm marine life by disrupting their habitat, affecting their health, and leading to long-term ecological damage. Now, here comes civil engineering solution for these problems. We come up with BOOMS. BOOMS is an effective civil engineering solutions, as it's specifically designed to control the spread of oil on water during an oil spill. It OS to mitigate the impact of oil spill on marine life and water. Let me explain to you on how BOOMS work. To get started, BOOMS are deployed around the spill area. They can be anchored in place or left free-floating, depending on the spill situation and water conditions. The floating portion of the boom prevents the oil from spreading across the surface. The submerged skirt ensures that oil doesn't escape underneath, especially in cases of waves or currents. Now, once the oil is contained within the boom, skimmers or absorbent materials can be used to remove the oil efficiently. By these, containment reduces the affected area and makes cleanup operations more focused and easy. Now, these methods is a catch since it offers significant potential in mitigating water pollution. Here are references that we took from the internet.